Next step, to add the TIF files and create the STL file folder for the output. Now, basically, everything is now set up. If you want to use the code again, just add the TIF files in the same folder, then run the code. The first code I created was to create from TIF to STL. This running the program is easy. Just right click and run. It will read the files in the selected folder and it will process them one by one. And if it closes automatically, this means everything is finished. This is the STL file. If you want to open anyone, you can simply double click. You can see it in any 3D program. This is the water surface elevation for 5 years period for Tbilisi. And this is the first code, the first program. Now let's use the reverse program. Don't need this anymore. To close this. This is the STL files. I want now to convert all of these to TIF. So the next code I'm going to use is to convert STL to TIF. Just run to run automatically.
So what is this mesh lab software you are showing that you can open the file in mesh lab, but here you are executing this in ArcGIS.
The TIF, for the TIF, we need ArcGIS. For the mesh files, we can use a program like Mesh Lab or anything. You can check, see the 3D file, 3DM files with it. It's basically landscape program, not hydrology. So basically now I have here the final TIF after the code. You can check the final output in ArcGIS. For example, let's check 10 years. It's in the actual location and the original TIF file, 10 years, this one. Both of them have the same low value and high value. So, and both of them are in the same location, so it's fine. And also the final output exported STL. This one, the exported STL file for the landscape team is actually projected, not refined by 000 as they normally do. So this is better than what they are using in their programs. For my end, that's all. Several options. You can use 3DM to shift it manually, or you can use QGIS to shift the TIF using the georeference option. Just 1 point from the 00 location and 1 point from the actual location, and the entire TIF will be shifted.
So in this case, scaling is not impacted. Normally, when we use georeferencing, we need 4 points properly projection. So in this case, you are just using 1 point and moving that entire file from
Because
00 to
most
that
of
one.
the X or Y in their files are shifted, but they still have the same orientation. For example, this is a TIF analysis imagery georeference. I can add a control point, for example, in here and shift it to somewhere in here. If I click save as new, now I have a new projected file from the original one. This is the original, this is the shifted. So simply you can use the code. After that, shift it manually, use one or several control points, as many as you can.
But in this case, you have same projection. You are just shifting 1 point to other point. If the projection is different, original file is different, then your scale mean X, Y, Z, 3 coordinates will be impacted. So that is the my concern, because sometimes when we project the files, it is projected to that coordinate only x or y, but elevation is impacted, or sometimes y coordinate longitude is impacted. So uh, what is the solution for if you are unaware about the projection? What type of projection they have utilized in the file, or to sort out the projection issue?
They need to provide you with the minimum and high elevation. The Z can be adjusted using raster calculator. XY can be shifted automatically the same way like this.
But but
Yes, Abhi, go ahead, please.
what I think is before starting a project, we should set up, survey point for everything. I mean, Civil 3D has it, but Revit as a base does not have it. So when the file comes, from BIM team, they need to first check all the base points and survey points. They need to create one unique, I mean, not unique, but yeah, survey point should be same in all the templates. So I think that is, one of the missing steps, because hydrology gets the file, then you guys use in Civil 3D, but as soon as you transfer it to Revit, it's a different software and a different version. So I think the survey point should be same in all the files.
For example, these files I have created, if I put this in a 3DM and export them again to TIF, everything will be in the same X, Y, and Z location. It will be in the same zone. It will not change. So the point here, we can shift the original file for if someone using 3DM, he need to use the control points in the actual location before he starts. So everything will be fine. This file, if you create a new 3DM model, it will be located exactly at the correct dimensions. It will not be located at 000. This one was created to exclude the no data value from TIF. So the raster, the output files will not be that large. If I included the no data, for example, if you don't know what the no data is, this is our raster. But this raster is actually saved as something like this. The actual file record this entire image as a TIF. If I converted all of this to STL, the file will be way larger. The code I wrote will exclude the no data from the output, so it will not be included. You will only have the cells with the values only. So this was from the code I created to convert from TIF to STL. This is finalized. It will create the minimum possible file that can be utilized. So this is basically finished. This one is under development. Sometimes every time I use it, sometimes I add a few lines, I adjust it to make it faster. But it's basically working in its current case. This is the TIF file I created from the TIF. In here, you have columns. These columns was created to preserve the values. So the top surface already have the values. If the landscape team wants only the top surface, they can use any 3DM file, 3DM Rhino, to explode the file and delete the vertical value. The top surface is in a separate layer, so it will be fine. And
Okay,
this is
okay,
the original TIF file, and this is the converted from STL TIF file. They basically in the exact same location. None of them return to the 000 coordination.
okay. So they are at their original coordinates. I see
Yes,
that they are, yes. And how you gave the bottom of the STL file? Guys, let's see a thick layer, basically, which is going to base pointings at some elevation. Top points are topography is at their elevation, and the bottom is at some other elevation. So you can say specified in the code that keep this thickness of
I,
this STL file.
I specified in the code to convert the original X, Y, and Z
Okay.
to
So
rescale them from 000. So if the original TIF file, if this one is the zone 38, this one will be at the exact coordination X, Y, and Z values scaled from the 000 coordination from this value of the raster. See, for example, every point in here have XY coordination, but it's projected for zone 38. My code gets the coordination for zone 38, converted X, Y, and Z, projected from 0, 0, 0. So if you convert it to STL, and the STL will remain in the same location as the TIF file in the 3DM file. If you export it and retain it, let's run an example again. Let me delete this. There is nothing in here. I don't have any STL file in my PC. So let's convert TIF to STL. Now it's this is the files in my selected folder, and it's running step by step. This is my STL file. 1 second, just select all of this, Control X, create new folder. This is the original files. We'll add all of these in here. Okay. I need to remove the 10s from here. Okay, I think I can remove them now. Okay. Let me this. So this now, in here we have the original. Let's open the average one. The original zone 2. Not projected. Let me check. Oh, it's projected. Okay. The original one is located in here. I will run the other one from STL to TIF. But for me, STL to TIF is not finalized, so I need to work a little bit more on it. So this is the new 100 year. It's basically in the same coordination in the 38 zone, not in the incorrect one. And if I added the same raster, it will be in the same location. This code developed several times based on several process. This is why it is actually like that. So I tried it several times before. The code will run until it closes automatically based on all the files in the same folder. If
Okay,
if you have 500 file, it will work automatically. So it's fine.
Okay, understood. So I guess which I pick from it that we can specify the depth of that STL file which we are referring or we are
See here,
making from the TIFF file. Yeah.
see here, this is the original TIF and this is the converted from TSTL. Both of them have the maximum and minimum file. I exported the exact file and the output give me the exact file at the exact same location. See here, this one is here and this one is here.
And I can say that 336.37 is basically the base of the plate or base of the surface which we have made in STL, and 355
No,
is
no.
the top.
STL is a little bit different.
Yes, that's
Because
why I say what is the minimum of this STL file?
0.
So it means that it picks up everything from 0 and take it to the original surface.
Yes.
Yes.
And the difference in value is represented as column because every landscape 3DM file or a 3D file uses the STL differently. This is why I created a column, so the values will always be fixed. For example, if I use RHI, Rhino, anything, for example, let's open this file, import, and not this one, VCC, 0RTS, I know something light. This is it will be low. I think this is my latest file. Takes time. Extent. This is my STL file. I can simply select all of this, join, explode. Yes. So basically, I can come in here. The top surface remains and everything else. So if I change the view like this,
Okay, okay. That is sliced. You have sliced that.
yes, it's basically created within the same file a separate surface. So if I select all of this,
Okay, this is
delete.
okay. You're doing this in Rhino 3D. Okay.
Or any 3D, you can do it in Revit or anything. Now they have the exact top surface. They
Yeah, yeah.
can
The base is moved. Yes, it means we can cut that. You can say extra
so
area. That if I want to stop at not three, yeah, 0, but only 336, I can slice that remaining STL in Rhino. Understood.
Rhino or Revit, it will work the same. Basically, this is a separate mesh than the one below. The one below it was added to the to have the remaining values because sometimes it's returned to 000. So this is why I created this.
Okay, okay. Yeah. That is why quite useful. I didn't know that you can slice that STL file because it was thought previously when I worked with Flow 3D that what STL is created, you cannot edit it in Flow 3D, you cannot edit it any other software. But here you told that in Rhino 3D you can edit that STL. One
In this one, it will be defined from 000. But you can
Okay,
convert
okay,
it to
fine.
TIF.
Okay. Actually, there should be you can say a legend of showing what is the you can say XYZ direction in this 3D file. There should be a you can say an option, but I am not familiar with Rhino. The person who will working with can find that legend that this is the X direction, this is the Y direction, this is the Z direction because everything in Flow 3D works in the X direction. You need to give any
Uh,
more each
in
boundary flow direction
in
in the
in
X direction.
in Flow 3D, you can import a TIF file, right?
Yeah, yeah, of course we can import
So
an TFL.
so this is you can import immediately the original TIF file, so it will be fine.
Yeah, yeah, yeah. Understood, understood, understood. Thanks, thanks. That is quite informative. Thank you, Amar.
But for 3D, for Flow 3D, uh, more data can be added to define every material, but I was only interested in the top value, so I ignored all of that. I can basically I can add, for example, soil data, define every material, give it a separate code. So in Flow 3D, everything can be defined separately, but I was actually focusing on the top surface only, so I ignored everything else. But more data can be added to the STL file.
Yeah, yeah. Also, you are using MeshLab. I use a MeshLab and Minimagics both. The advantage with the MeshLab is that if you have closed conduit, underground closed conduit, you can zoom into the your pipe, and you will see the pipe like you are walking into the pipe, and you will see every 3D detail that has been made. Minimagic does not give this advantage to you.